Welcome to ePathshala lecture series on computer science. So the paper is on visualization techniques. Today's module is module 29, wherein we are going to look at single views and multiple views in visualization. So the learning objectives of this module are: this module introduces the concept of single view and multiple views. Here we can learn about the different types of multiple view visualization. We will also learn about the coordinated activities that are needed in the case of multiple view visualization, and we will also have a look at various examples of single and multiple view visualization. So what is a single view? Baldonado et al. Defined single view as a combination of set of data together with the specifications on how to display this data. So imagine a set of pairs, for example, which represents the time, the data set which represents the time, temperature, size and weight or some certain coordinates. These kind of data could now be displayed as a single view by utilizing a list, a scatter plot or some other appropriate visualization technique. Such type of data representation used by a single view is often referred to by the term form. So this is an example of single view visualization, wherein we can see that this is a Ebola data that is being provided with respect to certain years. This is also another one single view visualization, where we are having a look at the percentage progress guide, which talks about the percentage of progress that has taken place. Next one is a multiple view visualization, a system design in which two or more forms are used to display the same data is called as multiform. If two or more views enable the users to learn about different aspects of the conceptual entity, they may be called as distinct views. For example, two scatter plots visualizing the same data in exactly the same way would definitely neither classify as a multiform nor as distinct views. However, if one of these scatter plots display data in greater detail, users could observe data at a higher granularity and therefore might thus learn a different aspect of it. Then that is called as multiple view or as multiform visualization. Roberts says the term multiviews generally refers to any instance where data is represented in multiple windows. Baldonado also says that multiple view system requires some kind of distinct views. There are various types of multiple views that are possible in visualization. Some of the techniques that are useful to generate these kind of multiple views are overview and detail technique, focus and context view technique, difference view technique and small multiple technique. So let us have a look at this overview and detail technique. This is a good example of an overview and detail technique. This is a Tom Sawyer visualization that supports the data visualization as well as a visual interaction layer. So in the right hand side pan, we can see the overview of all the nodes and how they are being, all the hardware devices that are being connected in an entire network as such. Now in the left hand side window, we are looking at one detailed part of the network that has been selected in the right hand side window. So this is a part of the network that has been selected in the right hand side window, which is being displayed as a detailed view in the left hand side window with all the parameter values being displayed here. So this is a good example of overview and detail, wherein we can tell that in the right hand side window pane, we can have a look at the overview of all the nodes that are present in that network, and in the left hand side window pane, we see a detailed view of the selected nodes from the right hand side window pane with their parameter values. This is another example of overview and detail visualization. This is a geolocated Instagram post that provide an overview of the global usage of Instagram as such. Zooming in at a particular city, whereas here in this case it is a New York City, it reveals certain details. We can clearly see with respect to this city what are the areas that are using the Instagram the most and which are the areas inside New York City that are using Instagram least. Everything can be visualized with the help of this overview and detailed visualization. So the background part is the overview part, and in the foreground the object that has been selected or the object of interest is being shown as a detailed in the detail view window. Then another example of multiple view is a focus and context view. So in the focus and context view, we can see that the context information is given along with the focused part in a detailed manner. So this is similar to that of the overview and detail part, but here we can see the entire context information is given along with the focused part. So here is an example of focus and context view. This is a bifocal representation of the London Underground map showing the central area alone in full detail, whereas the outside part, the rest of the areas are shown as shown in the context view. This is also another example of focus and context view. These are called as Moir graphs, where we use the radial focus plus context visualization and the interaction for graphs with the visual nodes. We can see that here the entire context view is also given along with certain focus that are given to certain number of visual nodes. So the visual nodes that are of interest are given as a focused with more detailed information, and they are called as a focused nodes, whereas the nodes which are not that of much interest are shown in the context view. The next example for multiple views is the difference views. So in the case of difference views, we can see different patterns. So this is a very good example of the difference view. In the left hand side is the figure number 1, which shows the filter pane with many filter groups that are available here. So in left hand side pane, we can see there are various filter panes that are available, and we can filter out the data based on the selection that we perform on the filter pane. Then subfigure 2 shows the tree views of the compared targets. So these are the views of the compared targets that are being selected and are being compared. Then in figure 3 or in the third window pane, we can see that the difference scroll toolbar at the top. So each and every view that it matches with the window pane 2 is being shown in window pane 3 with the differences that has taken place. So this figure 4 shows the legend at the bottom. We can see that whatever is given in yellow color, it represents what are the data set that has been changed. The whatever is given in green color, it shows that what are the data set that has been inserted, and whatever is shown in the red color, that shows that the data that has been deleted in the third window pane. So this is a very good example of the difference view, wherein we can see that it is possible for the end user to select certain data points, and based on the selection that are being made, the information is being visualized in another window pane, and there is another window pane which also shows certain variations with respect to the previous window pane, with respect to the changes that has been made, namely the insertions or deletions or some amount of changes that has been made to the second window pane. So this is a very good example of the difference view, which also comes under multiple view visualization. The next one is small multiples technique. In this small multiple technique, these are a visualization concept which are introduced by Edward Tufte. He described them as the illustrations of postage stamp size and are indexed by category or a label, and they are sequenced over time, like the frames of the movie are ordered by a quantitative variable, not used in a single image itself. So we can understand that these are very small images which are stamp size images that are being generated with respect to some time value or with respect to some changes in the variable value, and which are seen as individual frames. So in other words, we can also say that the small multiples uses the same basic graphic or chart to display the different slices of the data set. So there is only one kind of visual that is being seen in all the frames if you see, but here the data that is represented in all the frames are going to be different. So this is a very good example of this small multiples. Small multiples can also show rich multidimensional data. without trying to cram all that information into a single or overly complex chart. Andrew Gehman's analysis of public support for vouchers is a dataset that is being shown here, which is broken down by religion or ethnicity, income and state. So this is a dataset that has been taken as an example and is being shown as a small multiple in the in multiple windows basically. So in all these multiple views technique, we can understand that coordination is one important component that is being needed. So what is this coordination and why it is so important in multiple view? Let us see. The coordination of views requires specifications or mappings that when changes are made in one view also affects the other views. Such mappings are also specified as coupling functions. Some coordinated activities that take place in visualization are brushing, which means that upon selection of elements in one view, the same or the related elements are simultaneously highlighted in other linked views, which is especially useful for multiform views to find the similarities as well as anomalies. Brushing is a coordinated activity that is which upon selection of elements in one view also affects the other view or is being simultaneously highlighted in the linked views. That is called as brushing coordinated activity. This brush metaphor usually refers to how and how much data is being selected. When the data to be visualized can be filtered or constrained by sliders or input field, drop-down menus and such, the term dynamic querying is being used in visualization. This can also influence the several views and also become part of coordination. Navigational slaving is another common interaction technique that happens in multiple views. This term describes a relationship between views in which the navigational actions in one view are propagated to the linked views. For example, the synchronized crawling that happens in side-by-side different views would be a form of two-way navigational slaving. So this is an example of synchronized scrolling that happens in two side panes. So this is some collection of information. This is the different collection of information. The same information is being depicted in a different form. So when I try to slide in the left hand side window, automatically in the right hand side window, the scroll bar has to slide and see to that both the windows are in synchronization with each other. So this usually happens multi-views or multi-form visualization. So here is an example. I have selected a particular object and that object is being displayed in the other window. It synchronizes with that object and it shows the display in the other synchronized or multi-form window. So if it is going to be the same item, same collection of information, or it can also be some different collection of information as such. So these are good examples. This is also called as navigational slaving. There are various challenges in multiple views. So if you look at the challenges, the learning time and effort required to use the system properly is more when compared to that of single views. In the case of multiple view, the load on the user's memory when using the system increases. Similarly, the comparison effect required when using the system also increases. There is a context switching effort that is being required when using this kind of system because our brain has to switch over from one window to another window. Then the computational power required by the system is also increased in this case. The display space that is required by the system will also increase because instead of one single view, we are supposed to show multiple views to the end user. Similarly, the design, implementation and maintenance of the resources required by the system also increases in multiple views. So these are certain challenges that we face in multiple view visualization. What are the rules that are, there are certain rules that are supposed to be followed while creating multiple views. So let us have a look at all these rules. The first rule is the rule of diversity, which states that we need to use multiple views when there is diversity of attributes, models, user profiles, levels of abstractions or genre. So when there is some difference or diversity in the case of attributes and models, we need to use multiple views in that case, which is called as the rule of diversity. The next one is the rule of complementary, which states that we need to use multiple views when different views bring out the correlations as well as the disparities. The next rule is called as the rule of decomposition, wherein we need to partition the complex data into multiple views to create manageable chunks and to provide insight into the interaction among the different dimensions of the data. This is called as the rule of decomposition, since we are dividing the data into various forms, or we try to create some manageable chunks out of the data that we have. The next one is the rule of parsimony. In the rule of parsimony, we state that you try to use multiple views in a minimal way. The second set of rules that also covers the view presentation and interaction, which also involves coordination, and they are given as follows. The rule of space or time resource optimization states that we need to balance between the spatial and the temporal cost of presenting the multiple views with the spatial and temporal benefits of using the views. The next one is the rule of self-evidence, which states that we need to use perceptual cues to make a relationship among multiple views more apparent to the end user. The rule of consistency also states that make the interfaces for multiple views consistent and make the states of multiple views also to be consistent. The rule of attention management states that use perceptual techniques to focus the user's attention on the right view at the right time. So these are various rules that are supposed to be followed while creating multiple view visualization. This is a summary of all the guidelines that has been discussed till now. So we can see that in the rule of diversity, the major impact is on the memory, the positive impact is on the memory that is being, because we don't have to memorize a lot of things, whereas there is a negative impact, that is we need to learn a lot. We need to, the system has lots of computational overhead as well as display space overhead. Similarly, in the rule of complementary, the memory usage is less. The comparison we are going to make is going to be very simple, and the context switching is also a positive aspect. Whereas in the negative aspect, we can see that learning, once again, the same learning, computational overhead and the display space overhead increases. By way of rule of decomposition, wherein we tell that the data needs to be decomposed into manageable chunks, we see that the memory and the comparison is going to be very less when compared to single view, whereas like in the last rule, here the learning, the computational overhead as well as the display space overhead increases. By rule of parsimony, they say that learning, computational overhead and display space overhead decreases, because the rule of parsimony states that we need to use multiple views in a minimalistic manner. So wherein the display space overhead is going to decrease as well as the computational overhead is also going to decrease. Okay. Whereas the reverse happens here, that is we need to, since we are going to show only less number of multiple views, the memory, the comparison as well as the context switching, everything increases. The next rule is the space-time resource optimization rule. So according to this, they say that the positive impact is on learning, computational overhead and display space overhead, which all reduces in this case, whereas the memory, comparison and context switching increases. By rule of self-evidence, which states that use the perceptual cues to make the relationship among multiple views more apparent. It states that the learning and the comparison is going to be a positive impact, whereas computational overhead is going to be the negative impact. By rule of consistency, which tells that the data as well as the visual should be in a consistent manner, the learning as well as comparison is going to be less, whereas a computational overhead is going to be more. By way of attention management, it tells that the memory and the context switching is going to be very less, whereas a computational overhead is going to be more. So this is a summary of all the guideline rules that we have seen so far for creating multiple views. Next one is the uses of multiple views. If you look at these multiple views, there are lots of usage of all these multiple views. We can see that the participants would be excited when they try to use these kind of multiple view system, because we are going to display the entire data instead of a single view in multiple views and multiple windows, and the end users will be very excited to use these kind of systems. They also learn very quickly, and they were overall quick to learn whatever information that is being provided to them in the form of multiple views. The users were also being satisfied being able to create exploration environments and with the ability to effectively use a coordinated visualization. The users felt exploring with their custom built system was effortless compared to the standard tools they were used to. So they can understand that these kind of tools helps them in exploring the data set that they have in hand much better when compared to the standard tools that are available. A variety of solution processes for the given task indicated the ability to creatively handle the system, that is, adjust them to their very own personal needs. So variety of solution they present that these kind of systems can be adjusted to their own personal needs. So these are certain uses of the multiple view visualization. So we have already seen that in the case of multiple view visualization, there should be some kind of coordination that exists between the various windows or between the various multiforms that are being displayed to the end users. So what are the coordination entities that are supposed to be taken care of? So let us have a look at the various coordination entities. The exact subject of coordination, namely the view parameter, data, the view, the parameter, data, process, events and aspects of displaying window are supposed to be considered here. The first one is a type. Very close to the concept of a type in a programming language. Coordinations have a type as well, be it primitive or complex type of coordination. So the type of coordination that is the type of coordination that happens between multiple windows has to be the same or has to be in coordination with each other. The next one is a translation between the types might also become necessary. And next, another coordination entity that needs to be considered is the translation aspect. So when I try to translate something in one particular window, similarly in the all other views or in all other multifold windows, that translation has to happen in a similar manner. The next one is the chronology. This aspect covers a coordinator's lifetime, dealing with how long a coordination process persists, and scheduling, dealing with matters such as synchronization or asynchronization. The chronology is also another one coordination entity that needs to be considered, because in whatever chronological order that is being displayed in one window has to be displayed in the same chronological order in the various other windows or in multiple windows also. The next one is the scope. The scope of a coordination restricts in terms of link ability, for example, whether any arbitrary entity can be connected. So what is the scope of this coordination? The coordination scope is being restricted with respect to link as well as the ability for linkage. Okay. So whether any kind of arbitrary entities can be connected and things like that. The next one is a granularity of links that happens between multiple windows. This looks at how many entities and how many views there are in coordination, as well as how many links an entity contributes to coordination. These are called as a granularity of links. The next one is a initialization entity. Here we look at how a coordination is being created and also how links between the entities are created is contained in this particular aspect of coordination. The next one is updating. Several update models can be applied. For instance, the user initiated updating, lazy updating, greedy updating, and these kind of updates can lead to inconsistencies in the multiple view that have to be resolved or even better avoided from the beginning. So updating is another one biggest challenge in the case of multiform visualization, because when we try to update the data set in one particular window or in one particular view, that has to be reflected in all other views so that it has a consistent data set at the end basically. So updating is another one very important coordination entity that needs to be considered. The next one is realization. This aspect decides on general realization matters such as if and how to convey which entities are linked to each other, as well as how users coordinate and interact with each other. So, having looked at the various coordination entities, let us have a look at the various examples of multiple views. So, this is one interesting example of multiple view visualization wherein there are various windows in one single display. So, we can see various panes of windows, maybe 1, 2, 3, 4, 5, 6 windows are being displayed in this particular window pane. So, this is an information visualization tool with multiple coordinated views which represents network traffic analysis. So, we can see the data set that is being selected in the top window is being displayed in the bottom window in a more detailed manner, and on the right hand side we can get the data points of it. The data points are being visualized on the left hand side, and the kind of changes that are made to this specific data set is also being projected in the right hand side and another one window pane. So, this is a very good example of multiple view window pane. So, this is another example of multiple view window pane wherein the coordinated views are shown to assess the exploration of spatio-temporal data, that is the window's placement reflects the location on the map. So, basically I can place the window at any specific location and that reflects the location that is being displayed on the map as such. So, here we can see the various multiple views that helps in visualizing spatio-temporal data as such. This is another interesting example of multiple views wherein this multiple view approach is used for smooth information retrieval, that is a screenshot showing all 4 different views. So, you have one view of the entire region, you have the textual information related to that particular thing, you have the data set related to the particular visual that is being shown above. So, these are multiple views of the visual that is being shown in the left hand side window pane. Then there are other examples of multiple views. This is another one interesting example of multiple views wherein we can see that the coordinated and multiple views are also used in augmented reality environments. 2 coordinated scatter plots are being used in the top left hand side corner to get some kind of coordinated details out of it. This is in the case of augmented reality, multiple windows are also being used. So, this is the kind of multiplane calibration that happens in a multiple view. So, we can see that how the plane is being calibrated. The advantages of this kind of multiplane calibration is we need to require only a plane and you do not have to know the position or orientation of the plane as such. So, this is an example of a single view metrology in real life. This is how the camera parameters changes. In the case of multiple views, we can see that the intrinsic parameters like principal point, focal length and the magnification factor, the skew factor, as well as the extrinsic parameters like the rotation and translation which are related to the world coordinate system that is being displayed here. This is the real world multiple view as such. A person is standing in the middle of the room, how he views the real world as multiple views. So, there are lots of things associated with this kind of multiple view, that is you need to look at n linearities, we need to look at the multiple view reconstruction, we need to look at the Mandel adjustments, we need to look at the auto calibration, the dynamic SFM, the chirality and the duality associated with the camera basically. So, this is a multiple view geometry, an example for the multiple view geometry where A, B and C are the focal points. So, we can see that A, B and C, how they are being projected, calibrated, transferred and are being projected onto a screen. This is multiple view reconstruction, how actually the multiple view reconstruction takes place with the help of affine factorization and projective factorization it happens. This is with the help of sequential reconstruction technique, how a multiple view is being reconstructed. These are certain applications of multiple views of a typical scene. A scene which is being viewed in multiple views is being shown here. We can compute the camera motion from the video. We need to register the real as well as the virtual object motion. So, this is 3D modeling. In 3D modeling, how multiple windows or multiple views help us in modeling a perfect 3D model. So in the 3D modeling window, we can see that there is a top view, there is a side view, and then we have various views of the perspective view of the entire object. Everything can be seen in a single window as such. This is a projective 2D geometry example, how the two-dimensional geometry is being projected in different views to the end user with the help of transformations, cross ratio and invariance. So these are examples of projective 3D geometrical objects that are being displayed to the end user in multiple views by applying various transformations to these objects. So these are single view geometries which are being shown as multiple views to the end user using camera calibration, vanishing points and calibrating the conic as well as a IAC. So this is how the bundle adjustments is being done with the help of the camera, the maximum likelihood adjustments, that is being estimation that is being done for completing the structure as well as a motion. So this is another one example which shows that without any bundle adjustment the scene looks like this, and using the bundle adjustment how effectively they have reproduced the entire scene as such. So this is another example of dynamic structure from motion as such. We can see how dynamic objects are being created, or multiple view of or motion of the object is being created on the screen as such. So in summary, in this particular module, we have looked at the concept of single and multiple view visualization. We have also looked at various examples of single and multiple view visualization. We have looked at the various types of multiple view visualization. How coordination is a very useful technique that is being applied in multiple view visualization is also being studied. So this is a summary of the entire module. Thank you.